Every security breach usually starts the same way. Not with a code, but with access. The wrong user, the wrong permission, or a compromised identity, and everything else follows. My name is Michael Michal. In this session, we're focusing on how to secure access to your GitHub organization. We'll explore how users authenticate using tools like SAML SSO, 2FA, or multi-factor or two-factor authentication, and enterprise managed users, EMO, and how you control how they can access. So think about developers logging in, authentication. Look at how authorization determines what they can do, that is authorization. We'll also look at how to enforce policies and monitor access across your organization. So the goal is simple: make sure that the right users have access at the right time. Authentication is the front door to your entire development environment. Every action in GitHub starts with, do you have access? You access the code, you create a pull request, you manage the deployment. If that front door is weak, everything behind it is at risk. That's why passwords alone are no longer enough. Modern security requires stronger methods like two-factor authentication, passkeys, and biometric login. So instead of just using a password, a user might need a fingerprint or a security key to gain access. But here's the challenge. Security has to be strong without slowing developers down. So the goal is to design authentication that is both secure and seamless. GitHub supports several modern authentication methods, each designed for different scenarios. Let's break them down into categories. We have the passwordless authentication. Passwordless options such as passkey and web authentication. They replace passwords with biometrics or hardware keys, managing them with high resistance to phishing. For example, instead of typing a password, you log in with Face ID or a security key. Multi-factor authentication adds an extra layer of security beyond passwords. So GitHub supports push-based authentication with GitHub Mobile. And we have the app authentication. Authentication for apps includes OAuth app, where we can authenticate users, and GitHub app authentication separately with a second permission, or a scoped permission. So a CI/CD tool might use GitHub app with limited repo access instead of full user account. Finally, enterprise managed user, EMOs. These give full control to their identity, but no personal account, and all access is controlled centrally. So depending on your scenario, user login automation or enterprise identity, you choose the right method to secure access. SAML single sign-on is the foundation of the enterprise authentication in GitHub. It connects GitHub to your identity providers such as Microsoft Entra ID. So instead of managing credentials in multiple places, user log in once through your organization. So a developer signs in through your company login, and the same identity is used to access GitHub. But here's the important detail. Even after logging in, user must re-authenticate through the IDP, or the identity provider, when access sensitive resources, such as repositories. This ensures every access is verified against your enterprise security policies. So, as an admin, your role is to control access based on roles, monitor activities using audit logs, and finally limiting access to reduced risk. So the key idea here is SAML centralized identity adds security. It's enforced once and applied everywhere. Fine-grained access is another option. GitHub provides fine-grained personal access tokens. They allow you limited access to specific repository in action, rather than giving you full control. For example, a script can access one repo without exposing your entire organization. We also can assign roles and permissions at different levels. Repository level, team-based permissions. So a developer might have write access to one, but read access to another one. You can enforce policies to control access. So you can require two-factor authentication, restrict IPs, or block unauthorized application. This ensures only trusted access paths are allowed. And finally, access can be controlled at different levels, organization or enterprise. So authentication gets users in, but authorization ensures what they can access and what they're allowed and not allowed to do. When it comes to authentication, the goal is simple: strong security without slowing users. So GitHub recommends two key approaches. SAML SSO, so single sign-on, allows users to authenticate through your identity provider, central access, and policy enforcement. And 2FA, so two-factor authentication, adds that extra layer of protection even if credentials are compromised. So together, SSO and 2FA provides the strong enterprise-grade authentication while keeping the user experience simple. Let's walk through how to enable SAML SSO in GitHub. At a high level, the process is simple. You connect GitHub to your identity provider. This means you provide your SSO URL and the public certificate. Second, you test the connection. So before enforcing anything, you should always test the setup to ensure that users can successfully get in. And then you enforce SSO. Once validated, enforcing it, users who haven't authenticated will be removed. And at the enterprise levels, user will be required to authenticate on the next access. The key difference is, at organization level, it's great for testing. At enterprise level, we are ensuring consistency. So the goal is to roll out SSO safely, test it first, and enforce it at the right scope. When enable SAMLing SSO, one key decision is scope. You can apply it at either organization or enterprise. At org, SSO is ideal for testing or gradual rollout. You can enable it for single team or department without impacting everyone. At enterprise level, SSO applies across all organizations. This gives you consistent authentication policies everywhere. This is critical for compliance. Org level gives flexibility, enterprise level gives consistency. So start small if needed, but scale to enterprise-wide enforcement when you're ready. Even with strong authentication, like SAML, there's always one more layer you should add: two-factor authentication. 2FA adds a second verification step, like one-time code or security key, on top of the username and password. A user enters credentials, then confirms access using an authentication app or a hardware key. Why it matters? This dramatically reduces the risk of account takeover, even if credentials are stolen. So as an admin, you can require 2FA for everyone in your organization. If a user doesn't enable 2FA, they are automatically removed from the organization. This includes both accounts and service accounts. So before enforcing it, always communicate the change and give users time to prepare. So 2FA protects accounts even when passwords are compromised. Once you decide to use 2FA, the next step is to enforce it. You can do this directly in your organization setting. Just go to Settings Security and enable or require two-factor authentication. When you enforce this policy, any users without 2FA is automatically removed. This is why communication is critical before enabling the settings. The 2FA methods, you support a security key, that's the most secure option, using physical device, the Authenticator app, this is a recommended approach, SMS, less secure, because it uses a fallback. So a developer might use an authentication app for daily login with a security key as a backup. So enforce 2FA is a simple step, but it has a big impact on both the security and the user access. Before enforcing 2FA, it's critical to understand who is compliant. You can do this directly in GitHub. You can go to your organization, open the People tab, and apply the 2FA filter. This will quickly show you which users have and haven't enabled 2FA. So if you skip this step and enforce 2FA immediately, users without it will lose access. That can disturb developers, disturb automation, and even stop some critical workflows. So use this view, identify non-compliant user, and notify them in advance. So instead of reacting to access issues, you're prepared ahead and ensure a smooth rollout. So audit first, enforce second. So far, we've looked at authentication. Now let's talk about identity lifecycle management. This is where SCIM or SCIM comes in. SCIM stands for System for Cross-Domain Identity Management, and it allows you to automate how users are created, updated, and removed in GitHub. Instead of manually adding users to GitHub, SCIM keeps everything in sync with your identity provider. New employee joins, automatically added. Role changed, permission added. User leaves, identity and access is removed. GitHub supports native SCIM integration with a lot of providers, including Microsoft Entra ID, Okta, and others. There's also some custom where you can build your SCIM API to build those custom integration. So when HR adds a new developer in Enter ID, they automatically get access to the right GitHub team. No manual steps there. So SCIM eliminates any manual user management and ensures access is always accurate and up to date. Now that you understand what SCIM is, let's look at how to get it started. You enable SCIM in your IDP, in your identity provider. You begin with identity provider, like Microsoft Entra, enable SCIM provisioning for GitHub. Then you connect the GitHub. You connect GitHub by providing the SCIM base URL, the token. This will allow the identity provider to communicate with GitHub directly. And then you automate identity management. Once they're connected, new employee added, new employee created. Role change, permission added. Employee leaves, identity remove. So it eliminates that user access, user outages, or the needs for any manual creation. Now let's compare those approaches in GitHub, manual versus automated. With manual creation, you're responsible for adding, updating, removing. With SCIM approach, everything's done automated. New users, role change, and access is added and removed. So the difference comes down to manual is slower, error prone, and harder to scale. With SCIM, you're automated, consistent, and secured. So to eliminate the need for manually managing users, enable SCIM. When integrating Hub with your identity provider, you have two main approaches. What we call the paved path. This is supported with providers such as Microsoft Entra ID. Gives you faster setup, built-in support, less maintenance. And there's the custom integration. That's the advanced one. But it requires manual setup. So you need to build everything. You need to configure everything manually, step by step. So the choice is simple. Use the paved path for speed and simplicity. Use custom integration for flexibility and control. Most organizations should start with supported provider and only go custom when necessary. Once SAML SSO is enabled, there's an important detail many people overlooked. Credentials must be authorized. What does that mean? Even tools like personal access token and SSH key must be linked to the user identity provider. A provider using SSH key must authorize it through SAML before accessing organization repository. This ensures that all access, browser, API, or CLI is verified through your identity provider. So GitHub allows you to view active SAML session. This will show you sessions that are currently authenticated through your identity provider. If needed, you can revoke sessions if a device is lost or compromised, or you can immediately terminate the access. So SAML doesn't just control login, it also secures credentials and sessions across the environment. In GitHub, access depends on how users are connected to the organization. Personal accounts, every user starts with a personal GitHub account. This gives them access to public repositories and personal project. Organizational membership, that's when users join an organization. They get access to private repository based on roles. A developer might have write access in one team, read access in another one. Multiple organizations, now the user belongs to multiple organization environment. This means they have different roles, different access, and all of those. The key here is that this creates complexity. So organizations must carefully manage access, review permission regularly, and follow least privilege principles. It's not just about authentication. It's about managing access across multiple contexts. Now let's look at how to manage team access automatically. This is where team synchronization comes in. So we synchronize teams a similar way that we synchronize identity. How it works, when a user is added or removed from an LDAP group, from an IDP group, an identity provider, GitHub automatically updates the corresponding team. So you added user, removed user, the teams are there and they're synced. So the groups have the same access. Why this matters? Because it eliminates manual invites and ensures access is always up to date and the least privilege is automatically assigned. So instead of managing access in GitHub, you manage it in your identity provider, and GitHub just simply syncs whatever you have in your identity provider. It's ideal, first with onboarding. So when an employee is added, it's automatically created on the GitHub team. When the role is changed, when there's offboarding, the user just change. The important requirement here is to use Team Sync effectively. You need SAML SSO and you need SCIM enabled. So Team sync ensures that you're always aligned with your organization structure, and that is done automatically. Now let's look at more advanced identity. Those are the EMO, or the Enterprise Managed User. That takes the identity management one step further, because with EMO, all GitHub users are fully managed by your identity provider. Users cannot use personal GitHub accounts anymore. All access is controlled through your organization. So when users join your organization, their GitHub account is automatically created through your system. And when they leave, it's automatically removed. This is the most secure model because it ensures only access to resources with enterprise account. They cannot create personal repo or join external organization. So EMO gives you complete control over identity, access, and compliance across your entire GitHub environment. So let's clarify an important distinction. Team sync versus SCIM. These two features are often used together, but they solve different problems. Team sync connects your identity provider to your GitHub teams. So, developer added to a group, removed from a group, this is synced. SCIM handles the full user lifecycle. It creates users, updates access, and removes accounts when user leaves. So when a new employee joins, SCIM provisions their GitHub account automatically. Team sync for managing teams, SCIM for managing users. So the most powerful approach is to use both. Now let's look at SCIM in real-world scenarios. SCIM connects your identity provider to GitHub and keeps your data fully synchronized. Let's say you're using Okta or Enter ID, a user is added, GitHub account is automatically created. The role change, access update, and the user leaves, their access is immediately removed. This ensures your GitHub always reflects a source of truth, which is your identity provider. So it eliminates any updates, conflicts, or any issues that might happen there. So SCIM ensures users' access is always accurate from onboarding to offboarding. So what about team sync and SCIM, and how are we looking at group sync, and how are we looking at team sync and group SCIM? So with team sync, as we said earlier, it focuses on team membership. So team sync does not create user. SCIM, it's the full life cycle. So creates accounts, remove accounts, add users, remove users. So it's for managed users as opposed to team sync. So think about it. Team sync for teams, SCIM is for users. You've now explored GitHub Enterprise. You looked at the authentication, the SAML, the 2FA, and SCIM provisioning and team sync. Let's take a look at a few questions. What type of user authentication is used to verify user identity against a known identity provider? Two-factor authentication, time-based one-time password, SAML single sign-on, short message service. And the answer is SAML single sign-on. You're an admin and you want to enable team synchronization for your organization. What installation permissions do you need to configure team synchronization on Microsoft Entra ID? Provide the tenant URL, read all users' full profile, generate a valid single sign-on for web systems, or enable SAML single sign-on. And the answer is read all user full profiles. Where does a user authenticate after enabling SAML single sign-on? With a GitHub login, with organization credentials, with the identity provider. The answer is with the identity provider. So in this session, we saw how to balance seamless developer access with robust security controls with GitHub Enterprise environment. We began comparing single-factor, username and password, SAML SSO, 2FA, and a lot of really cool features. We also covered identity provider integrations with tools such as Team Sync, SCIM. So we learned about the major IDPs and how can we connect them with our system. We also looked at implementing SAML SSO and two-factor authentication. Thanks for joining us for this session. To continue your learning, watch other videos in this course or explore more on Microsoft Learn at aka.ms/learn.